In this lesson class, we're going to take a look at deciding whether or not a polynomial is a factor. And to do that, we just use our synthetic division with this factor, x minus 1. So what we're going to do is we're going to say that we need the positive 1, because really x minus 1 is equal to 0, and so our actual root is x equals positive 1. Okay, so that's again why we're using the 1 in our little side box here for synthetic division. Now we take our coefficients, but we've got to make sure that we have perfect descending order. We've got 4, 2, 1, none. So what we need to do is make sure that we have a 0, x to the third. So we take our coefficients and have 2, 0, 3, negative 5, and 7. And now we go ahead and do our synthetic division by bringing down the 2. And then multiply by the 1, we get 2. Add, we get 2. Multiply by 1, we get 2 again. Add, we get 5. And then if I multiply, I get 5. Add these, I get 0. And finally, if I multiply that, I get 1. And if I add, I get 8. Now, here, what we're finding is that this is not a factor. Okay, so if it goes in evenly, it would have a 0 as a remainder, but this one has an 8. So this is not a factor. Now we're going to take this information of figuring out if something is a factor and apply it towards factoring polynomials. Now, this one, of course, didn't work, but let's take a look at this next example. This next example, what we're given is that negative 3 is a 0. So negative 3 is a 0 of f. So it's asking us to actually factor it, given a 0. Well, why this is helpful is because, like this last problem, I showed you we actually gave the factor, and then we could actually figure out the root is 1, and that's what we've been doing over here. We use the root for synthetic division. Here we have a root, and we need to treat it as if it came from a factor, because it actually did. The reason that we have negative 3 is because we actually have x equals negative 3. And that came from x plus 3 equals 0. Okay, so this is a factor. So what we can do is actually use this root and synthetic division to find the remaining factors. Okay, so we're going to go ahead and take our negative 3 and do synthetic division with 6, 19, 2, and negative 3. And again, make sure we had 3, 2, 1, none, so we didn't have to add a 0 this time. And then we go ahead and do synthetic division, again with the negative 3 because that's the actual root, not with the positive 3 because that's the factor. So we bring down our 6, we have 6 times negative 3 should give you negative 18. And then I subtract, and I should get 1 times by negative 3, I should get negative 3. And that should give me negative 1 times by negative 3, that's going to give me positive 3, and the result is 0. So of course this goes in evenly because this one actually told us it's a 0. Whenever it is a 0, the remainder should be 0 after doing synthetic division, because again, it should go in evenly. So what that means is that this original equation has a factor of x plus 3. So what that means is I can actually write this as x plus 3 times, this is x to the 0 power, x to the first, x to the second, 6x squared plus x, 1x, minus 1. And that's equal to the original equation we had, which was 6x to the third plus 19x squared plus 2x minus 3. In other words, if I actually distributed this factor times the result from synthetic division, I would get the original equation that I started with because they told me it was a 0 and I factored. Okay, but the goal isn't to work backwards here. The goal is to continue forwards in factoring. It says factor the polynomial into linear factors. Well, what we did so far was we took our polynomial, which is raised to the third power, and we factored out a linear factor. This is linear because it's to the first power, and we're left over with a quadratic. So what we want to do here is continue to factor further as best we can for a quadratic, and the way that we do that is with our magic x. And if you factor with the magic x, we would multiply the negative 1 and the 6 on top to put negative 6. We would put the positive 1 on bottom, which means that I need 3 and 2, and I need the 2 to be the negative because 3 minus 2 is positive 1. 3 times negative 2 is negative 6. So I take these and divide by the 6x. and that reduces. The 3 reduces to a 1, the 6 reduces to a 2, and the 2 reduces to a 1, and the 6 reduces to a 3. So what that means is that I have factors, linear factors, of 2x plus 1 times 3x minus 1. And then again my previous linear factor comes down, and I've got x plus 3. Now, if I was to actually multiply all this out, FOIL, and then continue to distribute further, I would end up with this original equation, which means I have factored it completely, factored this polynomial given 1, 0. So again, the step was I used synthetic division to break it up, break it down, and then continue to factor further using magic x. Now, on this next slide, what we're going to be asked to do is find remaining zeros. Okay, the remaining zeros means that I know that I have negative 3 as one of my zeros, and you're going to be asked in some of your homework questions to do what we did on the last problem, which is to just factor, and then other problems, which it says find remaining zeros. Well, in order to do this, find the remaining zeros, we have to do what we did on the last slide, which is actually find, it means first find all the factors, okay, and then set them all equal to 0. So find all the factors and set them equal to 0. So basically what we're doing is doing all the work that I just did on this last page, and then once you get down to the end, set this equal to 0 and find each one of the answers. So what that means is I already have this one. This one is equal to negative 3. Okay, now I set 2x plus 1 equal to 0, and that's going to give me x equals negative 1/2. And then I set 3x minus 1 equal to 0, and that's going to give me x equals 1/3. So my remaining zeros are negative 1/2 and positive 1/3. Okay? So when you see this type of problem, when it says find the remaining zeros and they give you one of them, it means you need to go through, set up your synthetic division, and do the exact same process I did on the last problem, factoring the result from synthetic division, and then with your factors, set each one equal to 0. Okay? So again, these were my final answers.